Good morning, student. Today I am your teacher here again with a new chapter. Yes, today I am going to teach you the new chapter, that is motion and time. So this is the very new topic for you people. Listen carefully. Okay. So first I will explain you about the motion. What is motion? Motion is the change in the position of an object with respect to its surrounding in a given interval of time. Okay, means if anything is moving, it will change the position and it will also take the time to change the position from one place to another place. Then it will be termed as motion. So once again I am telling, motion is the change in the position of an object. If any object is moving, that means its position is changing, and when the position is changing, for changing the position the time is required. So that will be termed as motion. Motion is the change in the position of an object with respect to its surrounding in a given interval of time. SI unit of motion is meter per second, which can be expressed as m for the meter, per sign is used for that, and for the second SEC is used. So SI unit of motion is meter per second. So for the motion, different examples can be there. Motion of a simple pendulum. If you will see the pendulum, it keeps on moving, giving to and fro motion. So that is also a type of motion. Motion of a moving bicycle. The bicycle, when you ride a bicycle, it moves from one place to another. That is also an example of motion. Motion of a flying mosquito. Yes, the flying mosquito which keeps make the buzz sound near to your ear and it's keep on biting. So moving flying mosquito is also a type of motion. Motion of a merry-go-round. Merry-go-round, you have seen that there is a small doll, dancing doll, and it keeps on moving. Okay, so that is the motion of the merry-go-round. Motion of the blades of a fan, it keeps on moving, rotating. Okay. Motion of the earth around the sun. Yes, earth revolves around the sun. After that, motion of a striker moving on a carom board. When you are playing carom board and you strike the striker, so it moves and hit the coin. So that is also a type of motion. Motion of a stone falling freely from the roof of a building. So if you will drop one stone from the roof of the building or the terrace of your building, or from the balcony of your building, you will find that it moves downwards automatically. So that is also a motion. So these are the various examples I had given you people for the motion. So with the diagram you will get a very clear concept of the motion. See that the person is moving from one place to another. That is a motion. It is with the time, means the position has changed, and for changing the position a time interval is there. Bicycle also, if you ride a bicycle for half kilometer, you will need some time to cover that distance. So it is also a motion. Car moves with the speed from one place to another, that also needs a in an interval of time. Train, so this is also a motion. Now more pictures you can see. Top, after that you can see the aeroplane, the needles of the clock. Bicycle is there, to and fro swing, that is also a type of motion. Up, down, when it's moving up, position is changed, coming down, position is changed, and during that time, during that particular motion, it takes some time. So this is also a motion. Now you will find a girl swinging. Okay, so when the girl is swinging and the swing moves to and fro, it is also a type of motion. So I hope you people have understand the motion very nicely. When anything is moving, then it will have the some speed, either very high speed or very slow speed or very low speed. So speed is the distance travelled per unit of time. It is how fast an object is moving. Means any distance travelled in a unit time is termed as speed. Speed is a scalar quantity and SI unit of speed is meter per second. Formula of speed is also given, speed equals to distance by time. Okay, it is a scalar quantity. So this is a new word, scalar quantity. So in reference to scalar, one more word you will come across is the vector quantity. Time and distance formula, to find out the time equals to distance by speed, distance equals to speed into time. So these formulas you people have to learn. Now yes, we come to our topic, the name which I had taken, that is vector and scalar quantity. Okay. Physical quantities are classified into under two headings. That means whatever the quantities are there, weight is there, mass is there, okay, speed is there, distance is there. So these quantities are termed as physical quantities. So it is kept in the two categories. One is the vector and another one is the scalar. A vector quantity is any quantity that has both magnitude, that means the size, and direction. Okay, means how much. So if any physical quantity is having a particular direction also and size, means how much, magnitude, that will be termed as vector quantity. For example, velocity. When we say velocity, it means speed in a particular direction. Okay. When we say acceleration, so it is also in a particular direction. When we say force, so when we put the force is also in a particular direction. Okay. Now scalar quantity, it is the quantity that has the magnitude only but not the direction, is taken into scalar quantity. Example, speed, it do not have any direction, pressure, no direction, okay, temperature, no direction, energy, no direction. When we say force, it is we apply in a particular direction, but when we say energy, we are just applying the energy, so it is not having any direction. By this picture you people can understand it more properly. A scalar is a quantity that is fully described by the magnitude only. It is described by a just single number. Some examples I had told you, speed, volume, mass, time are the scalar one. So speed of a car, that means we are not indicating any particular direction. Weight is a vector quantity. Okay, a vector quantity is that both magnitude and direction. Okay, and vector quantities are important in the study of motion. Some examples of the vector quantities include force, velocity, momentum, etc. Now see, this cow is indicating the scalar quantity. He is telling that I am a scalar, I don't have any direction. Okay. Now this van is indicating vector quantity, is telling I am a vector, I know where I am going, I know my direction, I am having a particular direction. So this is the difference between the scalar and vector quantity. You people have to only know about this much. Okay.